So we're back here with Professor Rob Robson, and today we're going to talk about polymorphism. That's a pretty big word. What exactly is polymorphism, Rob?
Well, polymorphism means that we've got the same thing with different forms, and that is the literal meaning of it.
Rob, is that a bit like a baby that picks up something and thinks it's a phone? In fact, anything they pick up is like a phone?
Well, I guess it is. Because they look at different things and they say, hey, that looks just like this. Well, that's kind of what polymorphism is all about. The same thing in different forms. But that doesn't tell you everything about it. When it's applied to classes, it means the same sort of thing, but it means that a method in a subclass can override a method or the same method in the base class. So what we see is these are the same things because they have the same name, but because they have different definitions, they have different forms. So that's where we get the same thing in different forms, the same method name, but doing different things in the different classes.
So, say we have a method in a superclass, then how do we redefine that method in a subclass?
Okay, well, we've been working with our GameObject class, and we've got it up here, and you can see that we've got our GameObject class. We've defined the parts, the name, the position, and the image. We've got a constructor for it here. Then we get to have getters and setters for all of the variables, and I didn't list those. And let's just say that we're going to introduce a life force into our characters. But a game object isn't a character, so it doesn't really have a life force. So by default, here it is going to return 0 if you ever call get life force, because a game object might not be alive. So that is one of our implementations, and we simply say, okay, this one returns it like that, and that is one of our implementations. But over here, we've got our character class, and we say it extends the game class. And that's another word which means it is a subclass of the GameObject class.
Right.
So this is a subclass, and in here it declared a variable called life force. And if you take a look, it has the same method down here called get life force, and it returns the value of the variable rather than returning 0 as it did up there. So by providing a different implementation of this, we provide the subclass a different way to handle this than the parent class, and they really are doing the same thing. They're getting the life force which is appropriate for that particular type of object. Now, if you're a character, you actually have a life force stored there. If you're a game object, you don't. All you have are those variables, and therefore you want to do something different. So you've got exactly the same intent to find out what the life force of this object is. But depending on the type of object, it behaves differently when you ask for the same thing, but how it figures it out is done differently. And that's how polymorphism is actually done in code. And it turns out this is a very powerful idea, because here we have one object, and it doesn't really apply to it having a life force, so it returns some default 0 value. But when we get a character, which is a subclass of that, it really does have a life force. We have a variable to represent it, and we return that. At that point, it's meaningful. But if you think about it, a game object could be an inanimate object. It could be a car, it could be a table, it could be anything. And the life force of my table is 0. My tables don't run around or anything. But if I've got a character, a wizard or a warrior in my game, they do often have a life force. So now it will return something meaningful and tell me what the life force of that character really is.
So what can I use polymorphism for, Rob?
Well, you can use it for a couple of things. I'm going to start with the simplest situation first. And I'm going to say we want to create two variables and have them behave differently. So my first variable here is a variable of type GameObject, and I'm just going to call it OBJ. And I set it to be a new game object, and it's called home because it's going to represent my house and the images of a house, and I put it at a position 50-50. The second object is of type character, which is a subclass of GameObject. I'm going to call it my hero. It's a new game character. Its name is hero. It's at point 80 and 95, and I'm using the image of a hero to represent it. Now, here I'm going to call getLifeObject on the GameObject, and I'm going to call getLifeObject on my hero. Well, when I call getLifeObject on the GameObject, it is always going to return 0. But when I call it on the hero, it will return the value of the life force of a hero. So that might be something like 5. Or whatever the current value of the life force of that hero is. Because it's using the two different implementations of it.
So can I use polymorphism for anything else?
Yes, you can. And this is the most powerful use of polymorphism. So what we do is we create an array of game objects, and that's what I've done here. I said I've got an object list, which is an array of type game object, and I assign it to game objects. So it becomes an array of 2 game objects, but they don't exist yet because they're just going to be references or pointers to game objects. The first one, object list sub 0, I set to be my OBJ, which was my game object. And the second one I set to be my hero, which was a character. Then I'm going to call getLifeForce on every object in the list, and I'm going to write a little for loop here, which goes through and processes the entire array, calling getLifeForce on each one. Now, it's curious how this works because everybody's saying, well, which version of getLifeForce will it call? The game object, the object list itself is of type game object. And one of the things about object-oriented computing, anytime I have a subclass, I can assign it to a variable of the type of the parent class. Now this works on the theory that, well, you're a lot like your parents. And in fact, you know, your parents were probably Engs, and you're an Eng. So you've got something in common. So I can assign an Eng to another Eng because you've got that in common. So any of your children can be assigned to a parent class. So when I call getLifeForce, does it print out the OBJ version for the object, the hero version from the hero, or does it print the getObject version for both of them because it realizes, whoa, this is an array of game objects, and it invokes that because they're all game objects?
So that's the question. How does it know which method to invoke?
Well, I'll talk about that in a second. Right now I'm going to tell you what it does. And what it's going to do is the very first one is going to print out a 0, and the second one is going to print out the 5. So what it actually does is it figures out which type of object that it's working with. So now you ask, well, how does it do that? And that's a complicated question. So you remember way back a couple of our talks ago, I talked about a thing called the V-table or virtual table.
Okay.
And it wasn't very interesting back then because it was a way you could find out which method to call, but there was only one method, so it didn't really matter. But now we've got multiple methods, and it's becoming far more important. So right here, I've created my object representing, which is a game object, my hero, which is a character, and every one of these has a pointer to its virtual table. And there's one virtual table for the character class and one virtual table for the game object class. So the hero points to his virtual table, and he looks up get life force there, and it gets a pointer to this code, which executes his. The object has a pointer to another virtual table, which points to a totally separate piece of code, which does something different. So it's these pointers that every object has to its virtual table, and then it looks up the method in there, follows the pointer to it to find the code that implements the method for that class. And you notice that this code and that code are totally separate. So my hero executes one piece of code, and my object executes another piece of code.
Very good.
So that's how we can figure out which of the two methods we want to call.
So I see how polymorphism can be really useful to us.
Yeah, it's a fairly useful tool, and often you find when you create a subclass of a parent class, the subclass has to be behaving slightly differently from the parent class, but you don't want it to behave totally differently. Now, I'll show you one of the classic examples. And this is probably one of the most common examples you ever see of this. And we're going to start with a class called, let me just get my pen here. We're going to start with a class we're going to call a shape. Whoops, now I've done it. I've broken my line. Well, my line's going to be crooked. That's too bad. With these fancy drawing tools, I still can't make straight lines. It's awful. Okay, so this is going to be my shape class. And I'll just draw in S-H-A-P-E. And within there, it's going to have a method. And that method is going to be called draw. And every time I call that, it is going to draw that shape. Now, how do I draw a shape, Dan?
I have no idea.
Well, that's everybody's problem. Nobody knows how to draw a shape. Well, let's say we create a subclass of that. Okay, so I'm going to create one subclass here. And I'm going to say that this is my circle class. And that it inherits or is a subclass of the shape class. Now, a circle is a very special type of shape. And in fact, if I draw it, I know how to draw a circle. You probably know how to draw a circle, don't you, Dan?
Sure.
Okay, so it's simple because every time we call draw on a circle, it's going to draw something that looks like that, approximately. Now, let's just say we come up with a different shape. And this time we're going to create another class. And this one I'm going to say this is really a triangle.
Mm-hmm.
And it is also going to inherit from the shape class. And my triangle is also going to have a draw. Now, its draw is going to be implemented differently, and
Yes.
it's going to draw a shape that looks like a triangle.
Right.
I could go on, and I could make another class. And we'll just call this oops. And I want to put that in, and I want to put that in. And this one is going to be called a square. Now, my square is also going to inherit from that, and it's also got a draw method,
Mm-hmm.
which will draw something that sort of looks like that.
Very good.
So every one of these draws has got different code in it because it's going to draw a different shape.
Right.
So here I've got a superclass, and the superclass could have common stuff like what's the position and what's the
Right,
color
right,
of the
right,
shape
right,
and
right.
things like that.
Mm-hmm.
But it comes back to one other question I had right at the beginning, and I said, Dan, you know how to draw a circle,
I do.
and you know how to draw a triangle
I do.
and a square.
Mm-hmm.
Now, how do you draw a shape?
I don't know. How do I draw a shape with a pen?
Well, that's it. You don't know. So here you've got this method called draw up here. And you don't know how to fill it in, do you?
No.
You don't know how to write the code for that.
No.
And we've got a very special word we put on anything that's like that. And we say that that method is abstract.
Hmm.
And it's abstract because we don't know how to write the code for it.
Mm-hmm.
Now, let's say you were building a drawing program that did something like this. And you would say, oh, I want a new circle. So you lay down a circle. Oh, I want a triangle. You lay one down. Oh, I want a square. You put one down.
Mm-hmm.
Does anybody say, I want a new shape?
No.
And you try and draw it? No. So it doesn't make sense to actually have a shape, other than the fact that it's a really convenient class for all these other guys to inherit stuff
right,
from.
Right.
And that is what we call an abstract method in an abstract class.
Hmm.
Now, there is one thing you can do with the circle, the triangle, and the square, which you can't do with the shape. And that is you cannot create an instance of an abstract class. And the reason you can't do that
Mm-hmm.
is because this is a really handy thing to have but it doesn't correspond to any real object in the real world.
Right.
So it makes our program nicer,
Mm-hmm.
but it doesn't make any sense to ever create one of these.
Yes.
So we can declare it abstract. And as soon as we declare it abstract, it says, well, you don't have to write the bodies of all the methods, because things like draw, I don't know how to fill in that body because I don't know how to draw
That's right.
a shape until you tell me which shape it is.
Correct.
So this turns out to be actually a nice thing to have.
Mm-hmm.
And so often we find that the superclass of a group of subclasses is actually one of these abstract classes
Right.
that can't be instantiated, or we cannot create an instance of.
Mm-hmm. That was very clear then.
Okay.
Very good.
Well, that's a good overview of polymorphism. And now we've got a pretty good idea of the basics of object orientation. I think where we want to go from here is getting some practice in how we apply these principles to
Right.
problems in the real world.
Yes, yes.
So if you come back, I'll tell you more about that.
All right. Looking forward to it.